This is a video tutorial for tutorial 5A, question 2. Question 2 gives us two graphs and asks us to sketch the graphs of y equals to f prime of x. We can use our graphing calculator to get a sense of the general shape of this. So here I'm using GeoGebra. I've sketched in the first graph for 2A. If you're interested, this is approximately the equation that I've used for all of these. These only give an approximation, not an exact equation. Nevertheless, it's enough for me to get a sense for what my graph will look like. So when I ask GeoGebra to sketch the derivative function, this is what I get, the function shown in red. What are the important parts of this? A few things to note. First, as x tends towards negative infinity in the original graph, y is tending towards 0. So going this way, we've got an asymptote y equals to 0. What does that mean? That means that the derivative is getting closer and closer to 0 as well, because the original graph is approaching a flat horizontal line, so which would have gradient of 0. So as we go towards negative infinity, this red line, the gradient line, should approach 0. As the black line, y equals to f of x, approaches 0, it goes up to infinity, its gradient gets steeper and steeper. That means that the derivative function, f prime of x, should also get steeper and steeper. After the asymptote at x equals to 0, the original graph starts at negative infinity and increases rapidly. This means that I've got a very, very positive gradient. So the gradient here is highly positive. That means it's going to be positive, but it's increasing at a decreasing rate. So my gradient is decreasing. When I get to the turning point at 1 minus 1, that's when my gradient crosses the x-axis. And then as I approach the asymptote at x equals to 2, my original function is decreasing at an increasing rate. And so, again, my gradient will go down towards negative infinity. Again, after the asymptote at x equals to 2, my original graph is again increasing, so my gradient is positive. Again, it's increasing at a decreasing rate, so the gradient is decreasing. And again, this graph is going to the asymptote y equals to 0. So my derivative is going to, the original graph is becoming closer and closer to a flat line. That means the derivative is becoming closer and closer to 0, which would be the gradient of a flat line. So those are the important features that I'd want to see in the derivative graph of f of x for 2a. What about 2b? So this is the original graph. Again, I haven't quite got this perfect for a couple of reasons. First, a is just being taken as 1 in this case. Second, this turning point is not perfectly above 4, it's at about 4.22. So this is, instead of being 4a, it would be about 4.22a. Never mind, it gives us enough to get a sense of what the gradient function might look like. Here's what we get. So the light blue graph is the gradient function. What do we see? As my original graph approaches towards negative infinity, so going towards the left, it's becoming closer and closer to the horizontal asymptote y equals to a. That is, it's becoming closer and closer to a flat line. As it becomes closer to a flat line, its gradient approaches 0. So that's why we see the gradient going towards 0 as we go towards negative infinity. But as we go towards the asymptote at x equals to 2a, we see that our graph becomes more and more negative, the gradient becomes more and more negative, and so therefore the gradient function also has an asymptote at x equals to 2a, where it's becoming more and more negative, going further down towards negative infinity. After the asymptote at 2a, we see our graph, it's coming from negative infinity, but it's increasing, and it's increasing rapidly. So that's why our gradient, although there's an asymptote at x equals to 2, it comes from positive infinity this time because the original graph is increasing. Increasing means the gradient must be positive. As the original graph increases, it has a turning point here. The original one shows it at 4a. I'm sorry, my one didn't manage to quite align it perfectly. It's at about 4.22. But what you can see is that here, if I have a maximum, directly below it, I will have my 0 for my gradient function. And then this graph descends, going towards the asymptote y equals to a. So my original graph is becoming closer and closer to a flat line. That means that my derivative graph should also be going closer and closer towards being a flat line. So that's what I would expect to see for tutorial 5A question 2.